right, good morning. Happy Sunday. We're back at it. Today is gonna kind of be a callback to some streams from long ago, in which I did more than one, worked on more than one project, and in fact worked on a different project other than Glowing Telegram. It's been the focus of streams for a long time. So the plan for today, though, is, and actually, I did a thing. I got a little extension that adds a little sidebar here where I can put in notes in Markdown, so we can have plans for the day for these things overall for the stream. In fact, let me just say plans for this stream. There we go. Oh, there are pages. Interesting. Cool. All right. I literally installed this extension like half an hour ago. So, but anyway, I was thinking, yeah, it would be cool to have a thing that would be visible as we're coding, to remind kind of what are we trying to do on the stream, right? Because generally on these coding streams, I have some sense of what I want to accomplish, and it's probably a couple of different things. Generally, that's been working on the Glowing Telegram project, and we're gonna start off with some of that to kind of wrap some things up. There was some stuff I was doing yesterday. Excuse me. Stuff I was doing yesterday with a thing we'll get into in a minute, and then after that, maybe it'll be the back third, or maybe somewhere in the middle. We're gonna switch over. I have the latest version of Godot installed, which is kind of like Unity. It's a game dev IDE and engine, and I've not done anything with it. I have looked at some documentation, although I don't think I even have that ready to go. So we'll have to. Basically, the second half of the stream is going to be me learning a new thing, and just trying to get some stuff set up and figure out how things work, and working on I don't know, we'll probably start with something simple, like maybe like a Pong clone or something, like one of the very first video game sort of things, and try to do it in Godot, something like that. And I don't know how far I'll get on that. I want to know, what does the coding environment look like in Godot? Obviously, I'm used to using VS Code, and we have Copilot and AI things that we can use, and I have a sense that maybe some of those things are not natively available in Godot, so maybe we can use both. I don't know. That's kind of what I want to figure out today. It's just kind of what's it look like for me to use that tool. But before we do that, like I was saying yesterday, I'd started to work on a WebSocket interface. Again, a new one. This is probably, I don't know if this is the last thing that we need to rewrite to kind of restore functionality from before, but I did get it mostly working. So if I come over here and we go over to Glowing Telegram front end, npm start, get that opened. You have to log in. Oh, okay, cool. You can see in the stream. Actually, let me make this bigger for the stream. There we go. You can see in my stream series records, I even already have a learning game dev with Godot as a series here. So that's gonna. The plan for now is that I may. What is the plan? I don't know. I may just switch off. So some Sundays work on game dev stuff and some web dev, and there's still a ton of things we can do with Glowing Telegram. Coming back to the Twitch chat features and There's other things that I have that are kind of just like need to be. I have plans, and all of those plans are actually in GitHub in the project. That's not the right tab. There we go. This one, right? Glowing Telegram planning has 39 remaining items in this needs review column. So this is just like my. Actually, let's rename this. You know, there's a name that I've seen for this at other places. It's just called an icebox, right? Stuff that I need to consider how I do and if I really want to. Is basically what's the stuff over here. Hey. And then do next. This is really just like to do. There we go. So in progress and to do is what I want to see how much we can get through today. Still reserving a good portion of the stream today for learning Godot. So all that being said, where are we at? So I have a couple of pull requests open. We have one for the front end that this is me refreshing myself of what I did yesterday, on what I did yesterday. So we reorganized a little bit with the front end because the new WebSocket API has authentication. The old one from prior to our AWS move did not, because nothing did. And so we needed to move the WebSocket provider component that I wrote to be inside of moved in a layout, I think. So it would be inside of the admin component. So it would have access to the authenticated identity. So if we have an access token, we're passing it into the WebSocket provider, and then the whole, all the layout of the app exists inside of that. Auth provider I updated because we needed the ID token from our user record here to provide to the WebSocket. I updated the hook slightly to say, hey, this is optional. We might not have the URL. We already had logic down below to check to see, it's further down, to see if the URL was provided or not. So, and then the structure of the message changed a little bit just because I actually was playing around with the what's it called, the nightly or the insiders edition of VS Code and the agents feature to see what it would be like for it to like throw together the WebSocket backend, especially because I had written all of these to-dos with links to docs, so I had like a lot of context about how I was thinking this was going to go. So I basically copied and pasted the tasks and gave it to the agent-based Copilot chat, and it worked okay. It got a little confused and it did some things I didn't like, but it did end up with a little bit of direction, giving something that is mostly okay. There were some rough edges and things that didn't exactly work out. Like, it was very insistent that what it was going to do was make this WebSocket API construct and then leave a bunch of placeholders inside of it, and then inside of the app stack, like, reach into the construct and change the placeholders. It's just not a thing you should do. Like, there's no reason to do that when we can just provide the necessary information to the component. So things like that, things like unnecessarily moving things. I did see it started adding some log retention settings, so I went back and added that to my general Lambda construct as well, because I liked that. I don't need to have infinite logging, infinite log retention for the Lambdas, so now I don't. But yeah, so let's actually pull up this construct. Web API, no, WebSocket something. Yeah, WebSocket APIs. Okay, so one of the things I decided to do is I didn't necessarily want to make a bunch of extra Docker images, repositories, etc. So I had Copilot write a lot of the logic for this as embedded Python code just inline in here, and that does make this kind of unwieldy. And I did end up in one case creating a separate file, mainly because for WebSocket Authorizer we do need, and some of these things aren't used anymore. Get rid of those. Some of these things, like I'm using this JWT library. This is not a standard library for Python, so I needed to install it. And that meant, well, I needed to do more than just provide an inline code blob for my Lambda function. But anyway, I'm getting ahead of myself. So broadly speaking, what this is all doing is we can create a WebSocket API in AWS's API gateway. And this says, hey, create an endpoint that stuff can connect to. And then my code can also connect to it via AWS APIs and say, push out this message to clients that are connected to it, right? So I could use this two-way, where like clients, aka my front end, could send messages. In fact, I think it is sending messages to the WebSocket. Right now, I don't have any intention of like doing anything with that. The main, why do I want a WebSocket API? So for those that are not like have followed along through the whole course of this, one of the things that we have here is we have a tasking system where I could do things like, hey, see the stream right here. Go ahead and fire off a job that ingests the videos from the stream into the application and make them ready to like be used in the video editor. So when I do that, that's going to take some time. That could take like an hour to do, right? So I have this little task drawer that can show me the status of ingestion tasks. And we can there we go. Okay, that mostly works. Anyway, one feature I used to have though was that when tasks completed or when their status changed, there would be a little dot that would appear here on the drawer to let you know that something had happened, and then you would be able to open the drawer. And if you didn't have desktop notifications from the browser silenced, you would get a notification saying, hey, this task changed status. It's now in progress, or it's completed, or it errored, right? So that was a function that I had built that used WebSocket. So the server would push a message into a WebSocket, and if I happen to have a tab open for the app, it would be connected to the WebSocket. The front end would get the message and be able to, receive that push. So that's the why, right? And so now that everything's moved to AWS, a lot of the infrastructure that I had built wasn't really suitable. It didn't really fit in, and so we built this. And the idea is that so I'm making a table in DynamoDB, a connections table, and so that is so that I can record for each user that connects to the WebSocket API what their user ID is and what their connection ID is from the WebSocket. And then we have a TTL, so like we don't need to keep those connection records forever, right? So this allows me to say, hey, what if a user has like 4 different tabs on 4 different devices where they're all logged in, and on any device I could get a push. In fact, every device get a push notification saying, hey, the status of the job changed, right? So what we need to do is put a message in the table when something connects. So there's this connect handler that does that, and the code is in GitHub to look at, and a lot of it's inline here. The part that's not inline is there's a new Python function construct that's a alpha version in the AWS Cloud Development Kit. And it's kind of nice because I can just pass it entry, like the path to where my main.py is, and it will automatically see that there's a pip file in here that lists my dependencies, and it will install them for me, and package it up and deploy it as a Lambda. Because all the other Python Lambdas I have are either like just a snippet of code, it has no extra dependencies, or I'm bundling it as a Docker image and I'm pushing it to an ECR repo, and I have a lot of extra code to do that. And I wanted something a little bit simpler here. This may break because it's an alpha version. This construct is, so we'll see. But yeah, because this is a little bit more complicated with the authorizer. We have to verify. The front end will send the JWT token that the front end has for authentication of the user to the WebSocket endpoint when it connects. And so this authorizer code gets run to verify that JWT against AWS Cognito. So we have to do our own authentication to some extent here. But then the authorizer can say, yeah, that's this user, they're allowed in. And so then we can tie the connection to a user. And so that's what the connect handler does. The disconnect handler disconnects. And now we can get into kind of some of the things I had listed and list the things to do. So I said handle disconnects. I think I've done this actually, because the Copilot had written some Python code here to handle disconnects. And basically this just deletes the item from the table based on the connection ID. So I think this works, but we can test this, right? So if I go over to AWS, and I use my secrets overlay, because secrets. And I log in, and then we turn the secrets overlay off. There we go. So if I look in DynamoDB, we have a table for connections. That's this one. And we can explore the table items. Interesting. There's nothing here. Isn't this connected though? Yeah, connected to tasks WebSocket. Ignore the forbidden. Yeah, that's because the application does send a message when it connects to the WebSocket, and right now it's not set up to actually handle messages, so it just sends back forbidden on that kind of like ping. There we go. Okay, so there's a connection. There is a connection. Now, what is this TTL? Local 844 tomorrow. Okay, tomorrow. Okay, good. So if I close this tab, that should result in a disconnect, and the table empties. Isn't that cool? All right, so if I go back here now, yeah, look, there's a connection now. Again, and it even stores the time when the connection happened. Nice. So this allows the backend to be able to say, hey, if I want to send a message to this user, this is the connection ID, or the set of connections ID, the IDs that it needs to send the message to. So, did that. That's good. All right, that was easy. We just had to make sure that it worked, right? But it was already there. So 2 more things to do for this. So make sure all task creation events capture the user ID of the owner of the task, right? So for the backend to see, well, when it sees the task's changes, how does it do that? So there's a task change handler that is the code that is run when a task changes. So this is the thing that's actually getting the records of the changes and is sending a message to every connection based on the user ID. So let's just say it does that, right? Well, how does it get notified when the status of a task changes, or anything about the task changes, really, technically? Well, we are using a feature where we say, hey, this Lambda function has an event source. So in other words, there's some source of events that exists in AWS that can be a trigger for the Lambda. So the Lambda will run when there are events. Well, what kind of events? Well, Dynamo events, apparently. And so this Dynamo event source lets us listen to a DynamoDB stream, which is something that captures every time a record in DynamoDB changes. So if we look at the tasks table, let's see, app stack, tasks table, data store, tasks table, just a little indirection. Here we go. So here's where we 3 months ago created this tasks table. And so what I did recently, like yesterday, I think, 16 hours ago, was I added the stream property, which says, hey, by default, it's turned off, but if you provide a value, it turns on streaming. So when an item in the table is modified, the stream view type determines what information is written to the stream for this table. So a stream is a way to get real-time updates of changes to your database records. And so here I'm saying new and old images, because what I want is I want a copy of the item before the change and after. Which typically, you can also say, just give me the key of the record that changed, give me the new image, give me the old image. So it's like the thing after the change or the thing before the change. But no, I want both, because in our Python code, we grab the old status prior to the update. On the assumption, and generally this is the case, once the task is created, the only thing we're updating in the task record is the status. So the Python code grabs the old status, so the old image, the status from that, and then the new record, and then it sends that, pushes that into the WebSocket connection to all of the clients that are connected for that user. So in the tasks table, we need to store a user ID to say, hey, this task is owned by this user. Now, I think this could get more complicated, where actually maybe there's like a collaboration feature, and so multiple people need to get notified, and so that would mean I would need to do this differently. Maybe instead of having a user ID on the task, I would have some kind of like grouping identifier, some kind of like team ID or something, and maybe that team is just one person or some kind of abstraction, right? But I don't need to solve that problem now, because I'm not trying to do that. When I try to do that, then I can make those changes. Try not to solve problems we don't have yet. So how? What is responsible for putting stuff in the tasks table? Well, we have a construct. I think it's like notification. It's definitely not that file. Task something. Task monitoring. There we go. So this code, this construct has a Lambda function, and this Lambda function is responsible for putting a record into that table. Let's see. Yeah, there we go. Unnecessary extra line there. So how are we going to change this? Excuse me. How are we going to change this? Well, the nice thing is, I recall this from, I don't know if it was the last stream. Yeah, it was the last stream where I was thinking about, how can I make sure that if I change this in the future, if I want to change like what data elements are being passed to the tasks, I will be able to find the places and get errors if I miss something, right? That's the great thing about using a type system to say, here's the shape of the data, here's what it's supposed to look like. Because if you change this to say, hey, I want to take a user ID always, then, well, this is going to then tell me any place where I am not doing that. Look, I even had a blank line there, just like waiting for it. No, not really. That was just because I was separating mandatory fields from required fields, but that's neither here nor there. So changing this interface for this method is going to impact every place where I was sending messages into the task monitoring system, which means I have a hint as to where I need to go find things. Also, I can go to references. Before I do that, let's finish updating this code though. So we are going to add a new expression attribute name. This is going to be user ID is user ID. In other words, this is the alias, the attribute name, that refers to the field in the document in DynamoDB, aka like the row, right? The record, the user ID. And then we want to add a user ID that is the user ID from the event. So this :user ID is an alias for the value that we want to store. And then we have a little bit of, I don't like that inconsistency. Let's do user ID like this. There we go. All right, so this is a little a list of all the things we want to set. And I did this a week ago so that if we have record ID, we can add to that set of things that we're setting. Get it? It's a set, as in it's a collection of things that are distinct, but it's also a thing used to set values. So it's a set of set parts. So that should be sufficient. That will make it so that as long as we are passing the user ID in the record to this Lambda function, which we are because of the kind of the way we built everything else, within the scope of this construct anyway, we will get a user ID in those records going forward. So, what did we break? Can I run TSC? Type check? That's on the front end. I don't think I have a do I not have a task for the backend to like type check? Oh, it would have to be inside of the CDK code. Let's just do that from the command line then. 'Cause I don't think I have a task specifically for doing stuff inside of here. Yeah. npm run build be booled build. So this will type check, and so I'm expecting errors here. There better be errors because we changed the interface of that method. There we go. So 5 errors and 3 files because we have a user ID field that's required, but we are not using it in the places where we're using that method. So let's find those files. And in stream ingestion. So this is basically just all the places where we are providing a way to monitor the status of background tasks. So how is this going to work? That is the part that I don't know yet. And maybe you'll odds. Oh, never mind. Take care of that. All right. So, how do I solve this? Well, what is this? What is the problem? Ultimately, the problem is I need a way of saying, hey, the user ID that we need to supply, it comes from something. Maybe it's this. Maybe that is the case, right? So, in some ways, I really hate that short circuit in my thought process, right? It just gave me an easy answer. Like, I can evaluate, hey, is this answer correct? Like, will this work? But I haven't really asked, are there other ways? Maybe those other ways are better. And in what way could they be better, right? What are the downsides of doing this way? I don't know, because I haven't even started to think about solving the problem. But let's talk about the problem. Just ignore this for a minute. The problem is that we have this render job construct, right? That's the name up here, right? And this infrastructure code, this infrastructure as code, is responsible for creating a thing in AWS. As in, if we go over to AWS Batch, we can see there's a job definition. And the job definition says, hey, how do we render videos to a format that can be uploaded to YouTube? That's what this job definition is for. And so this contains all these details about like CPU architecture, how are we running the code, right? So I have a Rust container that's going to doing stuff, and how is the container run? What options are passed to it? What are the environment variables it uses? Those sorts of things, right? How much memory is available and CPU is available for this job to run? So what we want to do, so there is there's a button in the UI that the user clicks. That, through a chain of events, so to speak, results in an instance of this job running. And from the UI, we identify what the record IDs are of the episodes we want to render. So in that chain, at the beginning of the chain, we know who the user is. At the end of the chain is the part where we say, hey, the job something is happening to the job, and we want to push an event to the task monitoring system, which ultimately pushes a change into the DynamoDB table that then results in a message being put on the WebSocket, assuming there's a user ID. So the problem is getting the user ID from point A to point B, right? Now, there aren't a lot of places that we could put data that would make it to the point where we would see it in at this point, right? We can't put the user ID in stuff about the job definition. It has to be in this specific it has to be visible in the event coming from AWS Batch, this batch job state change. Now, we already know, we think we know, that the record ID's parameter, which was originally passed to start the job, is available. So maybe this is really the only way to really effectively, I mean, there are other ways, right? We could do this a different way where we create a record somewhere that has the set of records ID and the user, and then we pass that ID to the job. And then that ID is what we have here, and we have to like somehow trigger some code that looks up the user ID, and then that is what creates it. Like, there are other paths that this could take that would do this. But we could probably just add user ID to the parameters for the job, right? So we would just need to do something like that. Now, where else do we need to do this, right? So where else are we referring to record IDs? Well, we need to also do the same thing here, sure. We have two places where we're looking for those events. So this is a reference to record IDs because this is passing the set of record IDs to the job, to the like the Docker container to be processed. We don't need to pass the user ID here. So I think that how is the job invoked? I think we create the job definition, and then outside of this construct is where we actually run the job. Also, 1 second. Oh, I'm surprised. Okay, that's fine. I'm seeing all these like d.ts and js files. That's because I ran the npm run build command, and it compiled a bunch of the JavaScript, but it is ignored. I guess I'll just have to ignore it myself. Anyway, so where is this used? Okay, in app stack, we reference it to pass it to API construct, right? So somewhere in API construct, yeah, we're passing these things to a render job submission lambda. So this is the lambda function, which actually triggers the job based on things. So here's where we're passing in the record IDs. So for this to work, this needs to pass the user ID. How does this get the user ID? Well, I think we can get the user ID because this is being invoked from our API. We can get the user ID from the event request context authorize reclaim sub. Maybe. Hold on. I think there's somewhere in my code base where I'm doing something similar. Yeah, here we go. I'm just gonna take this code and we're gonna go back to here, and we are going to do this. Cool. So that gets us a user ID, and then we just need to pass it to the parameters. Right, so we have a user ID. That's the user ID. Okay, so that should complete the chain, right? So the API, the front end calls our API. The API is an authenticated API. You have to already be logged in, and the API gateway will handle the process of passing information about the authenticated user to the Lambda. This Lambda then can get the user ID and pass it to batch.submitJob as one of the parameters. And then we already made the change to renderJob to take the user ID and pass it through and make it available. And strictly speaking, I don't know if this is necessary. I think this might only be necessary if we wanted to pass the user ID to the container, but I'm just going to do it anyway. I don't think there's any harm, but just passing the parameter in the submit job request should make it available here to be used. And so we can pass user ID to new event target, and that will set up the connection from the events from the batch job to the task monitoring status capturing Lambda here. Okay, so that's one. That's one of those. In stream ingestion, we have to do the same thing. We need to pass the user ID. How do we do that? for a second. So we have this step function, and the stream ingestion step function gets run when an API endpoint is invoked that says, hey, go ingest this stream. So the good news is I think we could do something very similar where the API will do a thing. Where we pass the user ID to the invocation of the step function, so it's available. The question is going to be, so this event, the one that I've just highlighted, step functions, execution status change. This event is coming from AWS. And this event is an event that tells us about what happened with the step function. I do need to see if this, similar to the batch one, will show details that are things that were passed in. If so, we can do something very similar. Otherwise, we do have this other event rule here that's a custom event that is being listened for. And potentially we may have to change the step function a bit. So let's go look up this. Let's see, information, event bridge target, event structure reference. Detail type, detail. You have, oh, here's an example. Okay. Right. I think I touched on this before, where the input is going to be some JSON. Also, they have, I don't know what's going on with these double quotes, but that's not right. An execution status event, change event, can contain an input property and its definition. For some events, an execution status change event can also contain an output property. If it's too big, the input will be excluded. If the escaped output exceeds an amount, it will be excluded. So yeah, you can check the input details and output details to see if that happens. Cool. For standard workflows, use the describe execution to see the full input and output. Here's what it looks like when an execution was started. We have a status of running. We have various things. The challenge is going to be, like, even if we had the user ID in the input, I don't know. I mean, it's possible. It's possible to get it out. We would have to do some extra work here. We need like a custom lambda that's going to like parse the JSON and then create an event and do things. And I'm not sure if I want to go down that road versus maybe having the step function generate some additional events, right? So let's take a look here at stream start ingestion start. So here's where we send that event, or rather, here's the definition of the task within the step function, where we say how to send the event about the task starting. So let's start with this, because this is something that I know how to do. We're gonna expect that there's a user ID in the input to the step function. I think that for that to be true, we need to do this. There we go. Because this setup state step happens before send start event, and this is actually looking at the raw input and then formatting it in a way that the subsequent step expects. So the only things available for this step are the things that are set in this object. So if I didn't include user ID here, it wouldn't be available below, and we can see that by looking at where this is used. So yeah, setup state happens first, and then send start event. So let's think about this. So this is all in the state machine method that we're using internally to define the step function. And then the step function is being invoked probably in an API.ts? Right here, right? So in our /stream endpoint, I pass some custom. How does this work? Actually. Oh, we just passed the request body. Ooh. That's not great, right? So if the input to the step function is just the request body, and I'm saying, oh, well, the body should have the user ID, then what I've just enabled the front end to do, granted you have to be logged in, but you could pass any user ID, any user ID, not just the user that logged in. So I think we might have to change this slightly. Rather than having this, how does the parameter mapping work? Can we do like nested structures? Let's take a look at some documentation. API gateway v2 parameter mapping. Context variable. Path parameters, request path, request body. Stage variables, static values. Could I get... Does context include... Yeah. Authorize your claims. Right, so I could grab context authorize your claim sub. Or whatever it is. I don't suppose you have an example of what the context object as a whole might look like. Ooh, here we go. Maybe here. But we haven't authorized her. The question is, how do I parameter map the identifier of the user to my API after they've gone through the authenticator? And the answer is not here. Yeah. We'll just try things. Identity, not account ID. Maybe Cognito identity. No. That's identity pool stuff. That's different from what we're doing. We're using user pools. There's a separate thing feel like probably it's this. Dot sub is probably what I'm after. Let's go back to here. So this is talking about like things that are available to use, but how do can I structure the request? The request body. So here's like a pinned header, right? So how do I build up the body that gets sent? How? You use request parameters to change requests before they reach your backend integrations. You can modify headers, query strings, or the request path. So not the body. It's interesting. Like what are we doing here? We're creating a custom mapping. And I guess that sort of makes sense because we're doing a thing where we're talking to let's go to the definition of this. Append header, overwrite header, remove header, query string, overwrite path, and custom. So HTTP integration subtype step function start execution. So maybe what I need to do is look at integrations, service integrations. Following table describes supported mapping request parameters, request body. So there's nothing where I can really like pull some information from one place, some information from the other place, and stuff it together. So I think, yeah, like this. You can plug the message and put it in message body, or you could take the whole request body and put it in message body, right? That's what we're doing here. What's that body? So I think what I have to do is I have to make a lambda. I'm gonna make a const. How do I want to do this? We can do stream ingestion start state machine. Well, you're partially right. Lambda. No, I just want to do like an inline lambda dot function. Yeah, and we'll do inline from inline. Yep. Hold that thought. So we just like index, a comma there. This is going to be. I'm just going to do Python. I like Python for little embedded inline things. Can we just do like, is there a 3 dot whatever? No, of course not. Yeah, so we need a state machine ARN, and we need some code that is going to do something like that. Yeah, although I don't care for the annotation. Let's bring that down to there. Handler function is called by HTTP API gateway v2 endpoint. Yep. I'm giving a little bit of context so it can write this for me more correctly. user ID. Hey, that looks familiar. Didn't we copy? Yeah, it's right here. Hold on. Yoink. Cool. Let's see. And then what I'm going to do is I'm going to say input data is stream. Wait, I think it's this style. Stream ID, user ID. Yep. So now, get. Ooh, is it? It'll just be body, right? And this would be somewhere where, you know, I could handle exceptions and return appropriate status codes like this. We could definitely try and return a 400 status code here if this is missing. This is going to result in a 500 if this throws an error or whatever anyway, so that's fine. Is this substantially different than what the existing API is doing? The existing one is just taking whatever's in body and passing it through, which is not great. It's not great. So this is better already. And then what we're going to do is we're going to delete all this, and this is going to be like HTTP. Oh, right. It's going to be HTTP Lambda integration. Handler doesn't exist. All right, I think this is the second argument, just the function. Yeah. Okay. Oh, it's not happy about some formatting. That's fine. We'll figure it out. Environment, and then yeah, that seems fine. Maybe Biome just decided it had enough. I think the other thing I need to do is I need to grant this Lambda permission to invoke the step function. Right? So that was something that was handled behind the scenes. Yeah, there you go. It knows. Add to role policy. Oh yeah, we don't need to do that. That's all handled by default. If I'm defining this Lambda in line like this instead of using my fancy construct, there's some stuff I want to turn on. Yeah, and put on a description. Timeout really shouldn't take that long. We want log retention set to be like a week, sure. What else am I forgetting? Yeah, I can't find name logs because I've not imported that. We don't need that integration there anymore. I really like the map, but unfortunately, hey, Chaz, how's it going? Well, we're gonna get some ads, and this is gonna be chillin'. Nice. Well, welcome on in. I am going to be taking a break here because Twitch wants to run ads, and as is tradition, I need to get up and stretch. So I'll be back. It's awful. You just like show up, and I'm like taking a break, but I'll be back in like 3